show that the limit of sine theta over theta as theta tends to 0 equals 1. So to do that, the first thing I'm going to do will be to put up a circle. In this circle, my center is O. I'm going to take a radius from O to A and from O to B. The next thing I'm going to do will be to draw a perpendicular from B that meets OA at a point C. So I'm going to take this. So here you have C. Now, this radius OB, I'm going to call it R. So the radius OB of this circle AB is R. So we have just drawn a perpendicular that runs from B to meet line OC at a point C. Now please take note that I can draw a concentric circle that has a radius OC, meaning that I can do something like this. Okay? Now, based on the diagram, you can now see something if we call this angle here formed, that is angle AOB. If we call angle AOB theta, and noting that theta is in radian, then you can now see the following. So we have three shapes. Let's bring out the three shapes. So I'm going to bring out the three shapes in this manner. So this is sector AOB, the big sector AOB that has a radius R. This is angle theta. This is a right angle triangle. I have a right angle triangle COB, and lastly I have within that right angle triangle I have a smaller sector we can call COD. Let's call this point here D. So I'm going to call this point D. Continuing from the last figure we drew earlier on, we have small sector COD with radius OC. So we have this small sector COD having radius OC, okay, and this remains theta. We have right angle triangle COB, okay. We have right angle triangle COB. We have big sector AOB with radius R. So from this diagram we now have the following, and based on this we are going to do the next thing I want to show you. Now if you recall from a topic called mensuration that the area A of a sector was defined as theta over 360 times pi r squared, assuming theta is in degrees. Now, if theta is not in degrees and we make an assumption that theta is in radian, take note that 2 pi radian equals 360 degrees. Okay? So, this is the area of a sector when the angle is assumed to be in degrees. But if the angle is not assumed to be in degrees, rather in radian, then the following happens. We are going to replace 360 degrees with 2 pi, and the formula becomes A equals theta over 2 pi times pi r squared. Pi of course cancels, and you end up having r squared over 2 theta. So this is the formula I shall be using for the areas of my sector. Another thing worth knowing, please, in proving what is above is the following. So you have the triangle, the right angle triangle COB. Okay? Now, the only side we know happens to be the hypotenuse. And if I wanted you to find what this side will be, what will be the length of this side CB, take note. The length of this side CB relative to theta, CB is the opposite and CO or OC is the adjacent. So the relationship between this side and R, the hypotenuse, through theta will be sine. It means that sine theta will be equal to CB all over R, implying that CB can have an expression R sine theta. Okay? And cos theta also can be used to establish a relationship between OC or CO and R. And that would imply having adjacent, which is CO, all over hypotenuse, which is R, implying that CO will have an expression R cos theta. So please take note that CB, the opposite, is R sin theta, and CO, the adjacent, is R cos theta. We need it also in this proof. So let us do the following. Let A1 be the area of small sector COD. Okay, COD. Then we have the following. A1, according to what we had established as the area of a sector, will become 1 over 2 OC squared times theta. Now, this would imply, since we had already established from that triangle that OC is R cos theta, then we are going to have 1 over 2 R squared cos squared theta. And let me bring this theta over here. So you have theta R squared over 2 cos squared theta. Next, what we are going to do will be to get A2. So I'm going to say let A2 be the area of right angle triangle COB. Then area 2 will be half base. The base in this case is CO or OC times the height, the perpendicular height, which is CB. Okay? Now, if you put in what we have OC and CB to be, this would end up giving you half R cos theta times R sin theta, which simplifies to half R squared sin theta cos theta. Finally, let A3 be the area of the big sector AOB. Then A3 will be half theta R squared. At this point, we now have three expressions for A1, for A2, and for A3. Let's go over to the next thing. Clearly, from the diagram we had drawn previously, you will notice that the area A1 is less than or equal to the area A2, which is less than or equal to the area A3. That is obvious from the relationship by that diagram. Now, this implies that whatsoever A1 is, in which case we previously had for A1 half theta R squared cos squared theta. This will be less than or equal to what we obtained for A2, which was half R squared sin theta cos theta, which in turn will be less than or equal to what we had for A3, which is half theta R squared, dividing through by half R squared. When you divide through by half R squared, you end up having theta cos squared theta remaining on this part less than or equal to sine theta cos theta on this part less than or equal to theta. Next, again at this point, because of the result we want to establish, which is to show that limiting value as theta tends to 0 of sine theta over theta is equal to 1, we would walk along that direction. That will inform what step you take next. So the next step to take is to divide through by theta. So let's divide through by theta. I'm going to say dividing through by theta gives cos squared theta, because theta would cancel the theta here, is less than or equal to, I would have here cos theta, I'm choosing my theta to divide 1 out of the two of them, less than or equal to, when theta divides theta, it will give you 1. Okay? Now, at this point again, you will notice, because of my result, I would have to do the next thing I want to do yet, which is dividing through by cos theta gives the next result. So if you divide through by cos theta, you end up having cos theta is less than or equal to sine theta over theta less than or equal to 1 over cos theta. Now, looking at the final expression we have, please take note, what we want to show is that the limit as theta tends to 0 of sine theta over theta is equal to 1. So what I'm going to do now is to take the limit of this inequality. So taking the limit of the last result above gives limit as theta tends to 0 of cos theta is less than or equal to the limit as theta tends to 0 of sine theta over theta less than or equal to the limit as theta tends to 0 of 1 over cos theta. So, as a reminder, continuing from this point, that the limit of this is less than the limit of this, less than or equal to the limit of that, please take note that this limit we had established will give you 1, because cos theta, when theta becomes 0, gives 1, is less than or equal to the limit as theta tends to 0 of sine theta over theta, and less than or equal to 1, because as theta tends to 0, cos theta gives you cos 0, which is 1. 1 over 1 will give you 1. So, now, the only number that lies between 1 and 1 itself is 1. So, since 1 can only be the number, that lies between 1 and itself, then limit of sine theta over theta as theta tends to 0 is certainly equal to 1. And this proves the problem. Please like, share, and comment on this video. Where is this video important? It is important to prove this because you'll be needing it in proving the derivatives of trigonometric functions.